Okay, so hello everyone. So today we will talk about assignment 7, week 7 for nickel and particle physics course. And obviously it will be for the previous year question paper assignment solution. So let's start. Yeah, so this is the first question. I hope you can see the screen. Yes. So, hmm. So the first question is use Kelvin-Okubo mass formula to find the mass of lambda baryon. Given the masses of the nucleon is Mn, mass of cascade is this one, and the mass of sigma baryon is this one. So give your answer into the closest integer in MeV by c square. So first of all, we need to check that all the masses are given in MeV by c square. So whatever the mass of the lambda will be there, that will be also in MeV by c square. So there is no problem in the unit conversion. Okay. So now I'm just writing that how many data are available. The data is like Mn is given, M cascade is given, M sigma is given. Now we have to understand what will be the value of M lambda. So obviously from this question we can understand M lambda should be a function of these three, right? Otherwise how can we understand, how can we get the value of M lambda? So M lambda should be a function of M sigma, M cascade and M sigma. But how they are related? How there is a relation between M delta, M lambda with Mn, M cascade and M sigma, that we have to calculate. Okay. So for the completeness, maybe I can draw one picture here. So how many particles are given here? N means neutron, then cascade is given, and then sigma is given, and they are asking for lambda. So maybe it will be very good if I draw that octet baryon octet. Okay. So for the baryon octet, there is neutron, there is proton. Actually, we should write it like small letter, so that will be good, because this is proton, this is neutron, right? And this is I3 and Y value. Let's say Y value or S value, whatever. That is not a big issue. So this is N, this is P, this is like sigma minus, this is sigma 0, this is sigma plus. And here also again it is lambda 0, right? And this is what? This is cascade minus, this is cascade 0. Why I am writing these things? Because here basically N we need can you please mute yourself? Yeah, thank you. Okay, so we need N, we need the information for cascade, we need the information for sigma, and we need the information for lambda. So that's why I'm just writing here for completeness, right? Okay. So obviously for here it is minus half, I3 value, this is plus half, and this is minus 1, and this is plus 1, and here somewhere it is 0. Okay. And here also this is like here, this is 0, this is minus 1, this is plus 1, like that. Okay, so they are asking that you have to calculate the value of M delta in the using of Gelman-Okubo mass formula. So what is Gelman-Okubo mass formula? Basically, obviously, I will not derive all the formula right now, because we will just use that formula to derive the mass of M lambda. So mass formula is like, for any particle, the mass will be A0 plus A1y plus A2 into I plus 1 minus y square by 4. So this is the in general formula. Okay, maybe sir has already told about these things, and how it is coming, that is also I think sir has already explained very well. So I am not going to explain this expression right now, but we will see that how it will help us to determine the mass of lambda in terms of Mn, M cascade and M sigma. Okay. So here a0, a1, a2, these three are some constants, some constant value. And m, we can see m is a function of nothing but y, I. You can see here y, and here it is I, and here also again y is there. So obviously m is a function of y and I. To know the, after knowing the value of y and I and a0, a1, a2, we can get the value of m as well. No problem on that. Okay. So firstly, I'm just going to write here the main expression. This is the main expression for our case. A0 plus a1y plus a2 I into I plus 1 minus y square by 4. This is the main expression. Equation number 1, let me write here. Now, for the neutron case, at the very first, we are having mn value. We have some values of mn, right? So for mn case, I am writing here mn. Mn is a0 plus a1 into, okay, so what is the value of y for neutron? Neutron has an expression b plus s minus c minus b prime plus d prime by 3. It is like that. Okay. So obviously c is the charm quantum number, b prime is the bottom quantum number, and t is top quantum number. So for neutron is made up with UDD. So there is no C, B, D like that, and also there is no strange particle. So it is only 1 because of the baryon number. So y is 1 for neutron. So what we will write? We will replace that y by 1. Then a2 I into I plus 1. So obviously neutron and proton are two members in that family. So I will be half. Half plus 1 means 3 by 2 minus y is 1. So that means 1 by 4. Right? So it will be the value a0 plus a1 plus, now you can see 3 by 4 minus 1 by 4. So it is 1 by 2. So a2 by 2. So mn is this one. So let me write here equation number 2. So mn has the expression a0 plus a1 plus a2 by 2. Now coming to m cascade. So for m cascade, what is the value of y and what is the value of I? These two we need to check. So obviously I means it will be half because cascade minus and cascade 0 are two family members in that family. So I will be half. For y will be how much? So y again here it is, okay, yes, cascade is y equals to minus 1. So that's why I can write here y equals to minus 1. So similarly m sigma I can write here a0 minus a1 because a1 into y was there, so y is minus 1, so a0 minus a1 plus a2 into half into 3 by 2. Okay, now see y square means minus 1 to the power whole square is again 1, so obviously it will be simply 1 by 4. Okay, so now what will be the answer? a0 minus a1 plus a2 by 2 because 3 by 4 minus 1 by 4. So it is 1 by 2. So this is m cascade. So that we can write is like question number 3. Now coming to the third one, m sigma. So for m sigma we need to check y value as well as I value. So I for sigma has 3 family, sigma plus, sigma minus, sigma 0. So 3 family members are there. So that means I will be 1 for this case, sigma case. And y will be how much? Y is 0. See here y is 0. So we are writing here y equals to 0. So m sigma will be a0. Now see y1 in a1 into y into 0. Y equals to 0. So that means there will be no contribution from a1. So there will be simply a contribution from a2. So a0 plus a2 into 1 into 2 minus 0. So it will be a0 plus 2a2. So this is equation number 4. So now you can see I have m sigma equals to a0 plus 2a2, m cascade equals to a0 minus a1 plus 2a2 by 2, and m n equals to a0 plus a1 plus a2 by 2. So these 3 equations we have and 3 unknown parameters we have a0, a1 and a2. So obviously from these three equation, three unknown can be calculated, right? So from that we can get to know the value of A0, A1 and A2 in terms of A main, M cascade, M sigma. Okay, but before going to this long calculation, we need to check for M lambda, what we are looking for. So for M lambda, what is Y value, what is I value? So obviously Y will be for M lambda, you can see from this picture also, Y is 0 because M lambda. And what is the value of I? I is also 0 because lambda is only one member in that family. So lambda I equals to 0 for lambda 0. And Y is also 0. Okay. So Y equals to 0. Again I equals to 0. Now I am writing that one. M delta equals to A0 plus A1 into 0 plus A2 into 0 plus 1 minus 0. So you can see A1, A2, none are there. So only A0 is there. So M delta should be equals to A0 only. Yes. Now from this equation number 4, 3 and 2, we just need to calculate A0 value. If we can get the value of A0, that's it. There is no other need of A1 and A2 for this mathematics at least. Okay. So I am writing here again equation number 2 and 3 and 4. A main equals to A0 plus A1 plus A2 by 2. A main cascade equals to A0 minus A1 plus A2 by 2. M sigma equals to A0 plus 2A2. So these three are expressions. So now let me do one thing. How can we calculate the value of A0? Because we have the main motivation to calculate A0 only. But the main thing is that there is a little bit coupled thing, right? So we have to first do like something this plus this. If this plus this will be there, that means A1 will cancel out. So if I write here A main plus M cascade, then what will happen? It will be like 2A0 because A0 plus A0, A1 minus A1, it will cancel out. But A2 by 2 plus A2 by 2. So that means it will be simply A2. So Mn plus M cascade equals to 2A2 plus A2. 2A0 plus A2. Now M sigma equals to A0 plus 2A2. Now you can see it's a very simple expression. How? Because if I write here Mn plus M cascade minus okay, that is also fine, or plus. Okay, so now this minus this. Okay, now you can write here 2 into this minus M sigma. So what will happen? 2 into 2A0 plus A2 minus A0 plus 2A2, right? So what will be the value? 4A0 plus 2A2 minus A0 minus 2A2. Now you can see 2A2 will cancel out. It will be 3A0 simply. Now we can have A0 is like 2 by 3 Mn plus M cascade, right? So A0 is 2 by 3 Mn plus M cascade. And you can see M lambda was simply A0. So if I write here M lambda is equals to A0, which is again equals to 2 by 3 Mn plus M cascade. Oh, sorry, here will be something minus Mn, M sigma. That is the thing, I thought that where it is going. Because as a whole there is this line, so 2 into Mn plus M cascade minus M sigma. So equals to 3A0. So A0 is 2 by 3 into Mn plus M cascade minus M sigma by 3. So obviously there will be a minus M sigma by 3. So this is the answer for M lambda. So the answer will be 2 into Mn plus M cascade minus M sigma divided by 3. Now we got the expression for m lambda in terms of mn, m sigma and m cascade. Now we will just put the values whatever it is given in that question of the different masses. So masses are like 940, 1239, 1329 and 1190. 940, 1239. 940, 1239 and m sigma is how much? M sigma is 1190. 1190 divided by 3. So what will be the answer here? If you just simply calculate that one, maybe I can calculate here also. 940 plus 1239 into 2 minus 1190 divided by 3. So 1056. It will be 1056 MeV by 6K. So see, actually there is an expression that m delta can be a function of mn, m sigma and m cascade. So how to calculate that one? We don't know the expression for m lambda in terms of these three masses. So what we did, we just calculated from the very beginning of the general expression of Galvin-Okubo mass formula, and after that we just derived A0, A1, A2. Actually we did not derive A1 and A2 because m lambda we have checked that is simply value of A0. So we have calculated A0 and after that we got to know that what will be the value of A0, and from that we know what is the expression for m lambda in terms of mn, m cascade and m sigma. Okay, so that is the case. And then we got to know that this is the value. I think this is a little bit lengthy process, lengthy question as well. But if it will be a little bit simple also, because we just need to remember this expression. That's it. We don't need to remember any other expressions. This is the case. If you just know that value, this expression, then you can understand any type of particles mass in terms of S0, A1, A2, and after that if something is given, you can just convert S0, A1, A2 in terms of that masses, and you can calculate the mass of the particle. Okay, so till now if there is any question you can ask me, because this is a
Excuse me, ma'am.
Yes.
Ma'am, we can use directly Gelman-Okubo equation?
This one?
No, ma'am.
That one you are talking, that this one. I also have that expression, like, yes, mn equals to 2 by 3. It is in terms of little bit modification. There is something, that something divided by 4 equals to something is there. Obviously the same expression is there, but it will be little bit modified version is there. But yeah, that you can use, but actually how this expression is coming from the main expression only. Okay, this is for in any type of particles. It is for any type of particle, and whatever you are talking about, that is only for the expression of m delta, m in terms of mn, m sigma and m cascade.
Yes.
Okay, yeah. So but let's say in your exam there is something else is given here, so you have to, obviously you can remember only one expression, you can't remember for other all particles expressions, right? So if let's say in exam there is some other expressions are given as in terms of some other masses, so for that case what you will do, obviously you cannot remember all the expressions. So for this case it's better to remember only one general expression, and from that you can derive. That's it. Okay, because this is only acceptable for if m delta, mn, m sigma and m cascade are given. If other particles masses are also need to check or need to calculate, then there will be a problem to have this expression, this specific expression. But I will prefer only this expression because this is applicable for any type of particles. Only it is a function of y and I value. That's it. Okay. Yeah. So actually whatever you told, there was something like I also forget these expressions because it's simply 3mn. You can see from this expression also 3mn plus m sigma, something like that. Then there will be like 2 into mn plus m sigma, something like that. It will be something. So this expression is also exactly same whatever we got from this expression also. Okay. So I will prefer this one to explain all the general problem. Okay, now coming to the question number 2. Question number 2 is which of the following reactions are allowed? Obviously, it's a very simple question. You can see by seeing that, by having a look on that. And I think this type of question we have already explained in the last class also. So we will quickly do that one. Which of the following reactions are allowed? So obviously, as I already told that which of the following reactions allowed means we have to check Q, B and L. These three are the main fundamental one, right? So Q is the electric charge, B is the baryon number and L is the lepton number, and lepton number should be conserved as Le, L mu and L tau. Okay. Now check one by one. First of all, let's say delta plus going to n plus p. So the charge is fine because it's 1, 0, 1. What about baryon number? Baryon number is 1 because delta plus is a baryon. Neutron is also baryon, proton is also baryon. Now you can see that baryon number is not conserved here. Baryon number is violated by 1. So obviously this reaction will not be happen. Now coming to delta plus going to pi plus pi plus. Delta plus going to pi plus pi plus. Again Q is satisfied, 2, 1, 1. What about baryon number? This is baryon, this is not baryon, this is not baryon because this is meson. So obviously delta B is not equal to 0. So that is also not going to happen. Okay. Now delta plus going to P plus pi plus. Delta plus going to P plus pi plus. Now charge. Charge is 2, 1, 1. Fine. Baryon. This is 1 baryon. This is also baryon. This is not baryon. So that is also fine. Now I am writing here delta Q equals to 0. Delta B is also 0. Now coming to lepton. Obviously we will not check lepton right now because there is no lepton particle here. So delta is also 0. Now if this is the case, then we need to check one more thing is that is strangeness. So delta plus is nothing but there is no strange particle S present. So this is 0. Proton is also not a strange particle. Pi plus is again not a strange particle. So again delta S is also 0. Why I am looking at S here? Because most probably if it will happen, that will be governed by the strong interaction. So if it is governed by strong interaction, it should follow delta is equal to 0. Now you can see that delta is indeed 0. So obviously that is not problematic. So now we can see delta plus going to P plus pi plus, that can be a allowed reaction. Now coming to delta plus going to pi plus pi 0. So this is also not gonna happen. If anyone can tell me what is the reason that it will not gonna happen, then it will be very good. Charge is fine. Can anyone tell me? I think it's very simple. So baryon is 1. This is not baryon, right? This is also not baryon. So delta B not equal to 0. So again this is also forbidden. Okay. So the correct answer is C. Okay. So which of the following reactions are allowed? The answer is C. Maybe we can go to the next question. Yes. So take the quark content of pi 0 as u bar. Its possible isospin value is how much? Okay, very good. Take the quark content of pi 0 as u bar. Its possible isospin value. So first of all, I will tell you isospin, I mean like I, and third component isospin. Third component of isospin is additive quantum number. Okay. I is also additive quantum number, but additive in the sense quantum mechanically additive quantum number. So what does this means? Here in that pi 0 case, one u is there and one u bar is given. Okay, so for u, okay, u d I, let me write here, I have so many spaces, so maybe I can write here u d I I3. So you know that u and d are, these two are in a family, so that means u and t has the same I value and the I value is half. This is also half, this is also half. So for I3 this is half, this is minus half, right? So for u this is half I3 value, and for d I3 value is minus half. But I value is again half and half for both the particle. Now coming to pi 0, whatever they are asking. For the pi 0 case, the content is u bar. So if it is u bar, that means I value is like one I1 is given and another I2 is given. I1 for u, I2 for u bar. So I1 is half, I2 is again half. Yes, this is bar, but still it has the same isospin, right? This is the antiparticle of u, but still it has the same isospin as half. So if it is a quantum mechanically additive quantum number, that means I can have the value I1 minus I2 mod 2 I1 plus I2 value. So if it is minus 2 plus, that means half minus half means 0, 2 half plus half, that means 1 in steps of 1. So obviously in steps of 1, in between 0 and 1 there is no point, that means I equals to 0 and 1. Okay, so take the quark content of pi 0 as u bar. Its possible isospin value is 0 as well as 1. Okay, till now there is no question. If there should be any question, you can ask me. Okay, maybe there is no question. Now coming to the question number 4. Which of the following could not possibly form an isospin triplet? Could not possibly form. Okay, let's see the statement. And isospin triplet means in that family 3 members should be there. Isospin triplet means that one only. In this family 3 members should be there, and for this case I will be 1 only, because if I will be 1, I3 will be minus 1, 0 plus 1, 3 member will be there, right? Okay, so how to know that which one will be isospin triplet or not? First of all, just remember this plot again, I3 versus y. Just remember that plot. Obviously, there are 3 types of plot in particle physics, right? One is meson octet, another one is baryon octet, another one is baryon decaplet. So these 3 are there in our particle physics plot, YI3 plot, right? Here, as they are asking that isospin triplet and whatever it is given here, that is QQQ concept. So obviously we will not take care about meson right now. That is simply a baryon question. So for baryon octet or baryon decaplet, what is there? Let me write here baryon octet first. So how it is looking? It is looking like that. Octet means obviously there will be a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, then here 7 and 8, like that, right? So here you can see what does this means actually. This means like here it is, I am writing N, it is P. Just understand the question, because obviously it's maybe a very simple question for you, but it may be possible that in any other exam there will be something different question. So how do you tackle that one also? So here I am writing NP, this is cascade minus, this is cascade 0, this is sigma minus, sigma 0, sigma plus, and lambda 0. So just check here, this is in a isospin state. Why? Because here minus half and half. I3 value is minus half and half, and I value is half for these two particles. For this case, sigma minus, sigma 0, sigma plus, this total forms a triplet state. Why? Because I3 is minus 1, 0, plus 1 for this family, minus sigma minus, sigma 0, sigma plus. Here it is a doublet, isospin doublet. So only you can see here that I3 case, the singlet, triplet, whatever we will talk, that will be simply a straight line parallel to I3 value, right? So this is a isospin doublet, this is a isospin triplet, this is again a isospin doublet. Okay? So that means we have to take care about these parallel lines on I3. Similarly for decaplet also, in that decaplet plot also you can see the similar plot, it is like that. So here whatever 1, 2, 3, 4 particles will be there, delta minus, delta 0, delta plus, delta plus plus. Here 3 particle will be there, here 2 particle, and here 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decaplet, as a whole 10 particles. So in that plot also, this parallel line along I3 giving a isospin symmetry, like isospin quadruplet, because here is 4 particles. There is 3 particle, that means isospin triplet. There is 2 particle, isospin doublet. There is isospin singlet, only 1 particle, omega minus. So why I am telling these things? I am telling these things because you can see, if they are asking about isospin triplet, doublet, quadruplet, whatever they are asking, that will be only the parallel line along I3 axis. We will not check this one and this one. This one and this one is not the isospin triplet or isospin doublet. Isospin doublet will be only this and this. Isospin triplet will be this, like that. Okay? Okay, so we understand that note that whatever the parallel line along I3 will be there, that will make the isospin triplet, doublet, quadruplet, singlet, like that. Now the second point we need to check, or we need to think. Let's say this one was there. Here neutron was there, proton was there, and cascade minus, cascade 0, and then sigma minus, sigma 0, sigma plus. So whatever the values are there, if I am going from left to right, okay, left to right of I3 axis, then what will happen? From one particle to another particle, you will convert to D. If I will come to right to left, then what will happen? D will convert to U. So why I am telling like that? You can see from example also. This is N. N is U, D, D. Oh, sorry. It is different. Sorry. This. I mean, like, I will tell what is the meaning. And P is what? U, D. U, U, D. So what does this mean? This means that in that family, if I am going from left to right, one D is replacing by U. D is replacing by U. I should not write like that. It should be D is replacing by U. Okay? And here, if I will go from right to left, then U will replace by D. You can see here. This is UUD. So from UUD to UDD, what will be the change on? U is replacing by D. Similarly for this case also. And for this case, let me write here sigma minus, sigma 0, sigma plus. Sigma 0 is UDS, that I know. So what will be the value of sigma plus? It will be like UUS, because one D will replace by U. I told you that from left to right D will replace by U. So D will replace by U. So from right to left it will be how much? It will be simply D D S, because one U is replaced by D. U is replaced by D. So D D S U D S U U S. So the one main thing is there to note, whenever we will go from left to right, then what will happen? One D will replace by U, and the vice versa will be from right to left. So only this thing is changing when we are going on the same parallel frame of I3. Now see the options. Option A, U U U, U U D. Now see here what is happening. U is replaced by D. That is fine. U is replaced by D when we are going from left to right. Sorry, right to left. Because right to left means I am talking that this is right, this is left. From right to left, one U is replacing by D. So U U D. Then U U U. It is coming as U U D. Again it is coming U D D. One U is replaced by D. So that means this is in a parallel line of I3. So that can be a isospin triplet. Now coming to C option. C option is what? U U S. Then U D S. Now see, U is converted to D. Now coming to D D S, because one U was left and that is replacing by D. So that is also a isospin triplet. Now come here, U U C, U U C. Then what will happen? U D C, because one U is converted to D. And in the next one, what will happen? U will convert it to again D. So D D C. So that is also forming a isospin triplet. Now come to B option. B option is how much? U U S. Then U D S D D S. No. U U S U U C U U B. U U S U U C U U B. But what I told you, that will not be a isospin triplet, because here U is not going to D or D is not going to U. So this type of transformation is not here. So that means it will not be in the isospin triplet condition. So this option will not be the isospin triplet case. But yes, you can tell me what is this. This will be like from here to here if I come, then S will change. Here to here if I come, then S will again change, like that. But in that parallel line of isospin triplet, doublet, quadruplet, there is no change in S. There is no change in B, there is no change in C. Only the change is in the U to D, D to U. That's it. But if I want to go from here to here, then S will change. Because in that first case also I told that S is like, here S is minus 1, S is 0 and S is minus 2. Now you can see from here to here if I want to go, then one S will come, because S is minus 1. So it was U U D. So obviously it will be for sigma plus, it will be U D S. No, I mean like we have to check the what is this charge also. So it will be like, this is UDS. So it is like US, because you can see U was there, but D is replaced by S, because for this case S was 0, but here S is minus 1. So obviously one S should be introduced here for sigma plus. So that is the thing, but it is not a isospin doublet triplet like that, because P and sigma plus are two different family members. So what I am telling that if we will look for the isospin triplet, doublet, quadruplet, singlet, we will have to check the same parallel line of I3, and here what is the change going on? Here the change is only in the U to D or D to U. There is no change in U to S or U to C or U to B or U to D, whatever. There is no change like that. So the option number B will be the correct one. Which of the following could not possibly form an isospin triplet? Okay, maybe I told a little bit elaborately, but it will be helpful. So that is the thing. If you have any doubt, you can ask me. Okay. So coming to the question number 5. Select the correct statements ranging the mesons K minus and K0. So whatever the options are given, before going to this option, I just want to tell you one thing which will explain all the problems in that question. Yeah.
टाइम नहीं है ना, आपको जो ही टाइम है 6 से 8 में कर लो।
बात करके देखो उनसे क्या बोलते हैं।
Hello, can you mute
मेरे
yourself?
पास तो है, उसमें ही तो है नंबर।
Do you have any question for me, Mukesh? Okay, maybe. If you have any question for me, you can ask me, or otherwise, please mute yourself. Okay. So for this case, select the correct statements ranging the mesons K minus and K0, and there are 4 options. Which one will be the correct option? We have to check. So to know the answer, we just need to first clarify one thing. The thing is like K plus and K0. These there is something in chat box. Fine, no problem. So this is K plus K0. This is in one family. And the antiparticle of K plus K0, that means K minus and K0 bar, this is one family. So why I am telling this one? Because that will solve all the options whatever it is given in that question. Why I am telling that? Because you can see K plus K0 is in the one family. That means what? That means K plus K0 has the value of isospin as half, because 2 members are there. Now for K plus, I3 is half. For K0, it will be minus half. Okay. Now come to if it is in the same family, so that means Y value will be same for K plus and K0. Okay. Now coming to K minus and K0 bar family. If it is in a family, then I will be half for both of them, and I should not write like that. I should write like this, K0 bar and K minus, because I3 will be half for K0 bar and minus half for K minus. Okay. Now I am just showing you that meson octet. In that meson octet, you can see here it is K0, here it is K plus. If it is K plus, then K minus will be here. If it is K0, K minus K0 bar will be here. So why I am writing here like that? Because I3 you can see this is minus half, this is plus half. Now you see K0 and K minus should have minus half I3. K0 is minus half, K minus is minus half. Fine. Now for K plus K0 bar, K plus is plus half, K0 bar is plus half. Okay. And also if it is Y value, so Y is same for these two. This one and this one has the same Y. This one and this one has the same Y. Right? So what will be the value of Y here? That we need to check. First of all, I will tell that for K plus and K0, both have same Y, both have same strangeness number, because Y is nothing but B plus S minus C minus B prime plus D prime by 3. This whole term is not right now in our condition, because all the particles we are taking care right now, there will be no C, B and T quark. So we will not take care of this one right now. So B will be simply B plus, sorry, Y will be simply B plus S. That means kaon, pion, whatever the meson we are taking care, mesons are not a baryon. So the baryon number will be 0 for this case. So Y will be simply S. So if same Y is there, that means obviously same S should be there for K plus and K0. And for K plus and K0, if you see the quark content, the S value will be plus 1 for K plus and K0. And for K0 bar and K minus, this case strangeness is minus 1, and obviously Y will be again minus 1. And for this case Y was 1, because same Y same S. Here also again same S same Y. K0 bar and K minus both have same S as well as same Y. I think it is clear to all of you the concept whatever I am going to tell. So now in that family, that means we have to remember that K plus K0 is one family, K0 bar and K minus is another family. That's it. Now check the options whatever given in that question. I told you K plus K0 in family and K0 bar K minus are in the second family. I mean one family. Now they are focusing on K minus and K0. That means they are focusing on here and here. They both have opposite strangeness. Opposite strangeness. This has a strangeness plus 1. This has a strangeness minus 1. So one is plus, another one is minus. So that is correct. But obviously K plus does not have plus strangeness number, but K minus has minus 1, K0 has plus 1. So both have opposite straightness, that is correct. Right? Now both have the same hypercharge. I told you Y equals to S equals to 1, Y equals to S equals to minus 1. So they are focusing on this particle and this particle. Now you can see for this particle Y is plus 1, for this particle Y is minus 1. So they both have same hypercharge, that is not correct. Now come to C. They have the same isospin but differs in the third component I3 by 1 unit. Okay. They have the same isospin. Obviously they have the same isospin because I is plus half, I is half, I is half. Two family members are there, so half. But differs in the third component I3 by 1 unit. Now let's check what is the I3 value for K0. I3 value for K0 is minus half. I3 value for K minus is minus half. So this is not correct statement, that differs only differs in the third component by 1 unit. Obviously it is not differ by 1 unit, this is the same I3 value. Okay? So K0 and K minus both have same I3 value, which is minus half. Option number D. They have the same spin. Now let me check, is it correct or not. For spin case, obviously this is a fermion, this is a fermion, so spin will be always half for any type of fermion. So it is also fine that they have same spin. So this is correct. So now you can see here what is there. There is something. Yes. Yes, you can unmute yourself.
Madam, is this K meson is fermion or boson?
Okay, fine, sorry. Meson is fermion or boson? You have to tell me what is this. Meson is boson or fermion? I mean, yeah, that is very good question. It's a boson, right?
Yes, madam.
Ha. And one more thing I will tell. Actually, I just thought that one. They have the same spin. That is also one type of same question. I mean, one type of correct, one type of wrong. I will tell that one. So this is meson. So obviously there will be an integral spin, right? This is not a fermion. This is a meson because it's like u bar, us bar, or something like that. So it is a meson. So obviously it will be a integral spin. But if integral spin is there, just I am taking one thing. In the next questions also it is the same thing. I will tell that one. So they have the same spin. It is correct or not? Let's say k0. K0 have a spin integer 1 or 0. Actually it will be 0, right? Or 1. Can anyone tell me what will be the spin for meson? It will be?
Perhaps 0.
Yeah, it should be 0, okay? But I mean, obviously it's a base boson, and boson is an integral spin. Integral spins means it will be 0, 2, 4 like that. I mean 0 into half, 2 into half, 4 into half like that. So meson have a spin 0. Now you can see K0 is a particle, right? And K plus is also a particle. The antiparticle of K plus is K minus, and antiparticle of K0 is K0 bar. So as the spin of K0 is 0, so there is no concept of 0, minus 0 or something like that. Obviously minus 0 is nothing. So spin we will talk as 0, and they have the same spin because these have the spin 0 only. I will tell in that next, maybe next to next question. There we will check that if one particle has the spin, let's say half, then for the antiparticle what will be the spin corresponding to that particle. That we will check. But obviously as there is only a 0 value, so 0 does not have any plus or minus like thing. So they have the same spin. That is correct only in the sense that meson has a 0 spin. Okay. So this is the case. Actually, I intentionally to tell that it is a fermion because maybe some of you will tell me, but yeah, fine, thank you. So they have the same spin. That is correct because they have the mesons, and for the meson case, if it is a 0 spin, that means particle or antiparticle does not have any different spin and all these things. So that will be 0 and 0 only. So for K0 the spin is 0, for K0 sorry K minus the spin is again 0. Now we can tell, maybe in the next question I have, no I don't have in the next question, but maybe in the next question I have. But okay, just see the next question. One of the D meson is made of a U antiquark and a C quark. So D is what? D, they are telling that U bar, antiquark of U is telling, so U bar and C, that means charm quark. So D has the quark content as U bar C. What is the electric charge, hypercharge and I3 value of this meson? So what is electric charge? Okay, very good. What is electric charge? Electric charge is simply a additive quantum number, right? So for U bar, what is the Q value for U bar? U bar will be, okay, for U, the Q value is 2 by 3 E, right? So if it is 2 by 3, then U bar will be minus 2 by 3. And C has also 2 by 3 E. So C has 2 by 3. So you can see that charge is minus 2 by 3 plus 2 by 3, that is 0. Okay, charge is 0. Now see the options first. There is two options, C and D, which has charge equals to 0. So obviously we have to check Y and I3 value, otherwise we cannot sure that which one will be the correct one. So U bar C, this is D. Now Y value and I3 value. Now first let's check I3 value, because I3 is again an additive quantum number, right? So okay, I3, U, D, let's say C. So for U it is half, this is 0, this is half, this is minus half, this is 0. So I3 will be u bar. U bar means this is half, so that means it is minus half plus 0. So it is minus half. I3 is minus half. Now come to y value. So q equals to I3 plus y by 2. Yes. So q is already we have checked. Q is how much? Q is 0. Q is 0. I3 is minus half plus y by 2. So you can see y by 2 equals to half, y equals to 1. So q I3y, q I3y, this combination, or this combination it is not given, this combination is given, q y I3. So this combination will be 0, y is 1 and this is minus half. Now see the answers. Correct? Okay. 0, 1, minus half. So D option will be the correct one. So how we have done these things? We have just done here, because of that q value at first we calculated. Q is for u bar, it is minus 2 by 3. For C it is 2 by 3. And then it will be like, what is that? Okay, minus 2 by 3 plus 2 by 3, it will be 0. Now coming to I3 value. I3 is like u, d and c, half minus half 0, 0. So I3 will be minus half. And q equals to I3 plus y by 2. So here we can have the value of y as 1. So q y I3 equals to 0, 1, minus half. So maybe the option is D. Okay. Yes. So in that question, we can come that match the items in the following two lists. Okay. So match the items in the following two lists. It is like proton, lambda 0, antineutron, K plus. And in the ABCD it is strangeness 1, UUD, baryon, spin minus half, right? Okay, so proton.
2 up and 1 down particles.
Yes, so proton is this, UUD. Now, okay, so lambda 0 is a
Baryon.
And antineutron?
Spin minus 1 by 2.
K plus? Obviously it will be simply strangeness is 1, because obviously K plus and K0 we already talked about that strangeness is plus 1. And for K minus and K0 bar, actually we should not write like that, it is K0 bar and K minus, this is minus 1 strangeness. So it's very simple. So maybe I can write it very carefully. 1B, 2C, 3D, 4A. Very good. Okay. It's simple question. Whatever. Okay. That's it. I did not have any other question. Okay, fine. Okay, so what I just mentioned here, I just listed some of the particles and their I, Jp, charge and age values. So why I have just mentioned here, because obviously we are dealing with so many particles, so it will be very helpful for all of you people to list some of the particles in their particle I, Jp and charge and age values. So you can see I have just mentioned here photon, proton, neutron, lambda 0, sigma plus, sigma 0, sigma minus, omega minus, then pi plus. You can see here also pi plus, pi minus, pi 0, these are the mesons, right? So here J means the spin, so spin is 0, 0, 0. I mean what we were talking, that K minus, K minus, K plus, K0, these are all mesons. So obviously 0, 0, 0 and then minus, minus, minus. Minus is nothing but the parity. And this is what? This is charge. Okay, charge and S. S is the strangeness quantum number. So I have mentioned that one. Now in the next table, I have just mentioned here some of the zeroth particle. Eta 0, cascade 0, lambda 0, oh, cascade minus is also there. Okay, fine. So, I mean, whatever the possible things are there, we have just mentioned. Now in the next one, I have just mentioned all the leptons like E minus, mu minus, tau minus, nu E, nu tau, all these things. and their charges and strangeness. Obviously, leptons does not have any charge quark, so obviously it will, sorry, s quark, strange quark. So that means obviously it is a 0 in the strangeness quantum number, because this is a fundamental particle, so there is nothing quark like that. And in the next one, what I did, I have just put here the quark constituents and with their particle numbers, I mean particles, and I3 value, S value, B value, Y value, Q value. And then there are some quark constituents are there. So maybe this much is very good for nuclear and particle physics course, as well as all the competitive exam on particle and nuclear and particle physics questions. And that's why I have just mentioned here in a group like thing, table like thing, so that it will be very simple to understand. So I think today I don't have much more. Oh, there is something. Okay, there is like pion eta k plus k minus symbol is there, and then isospin and with their masses. Why I have written here masses? Because these masses, in most of the questions you can see the pion masses is given, or most of the cases pion masses are needed. So obviously there will be some question where pion masses will be mentioned or it will not be mentioned, but we can just remember that one, the pion mass is 140 MeV. Okay, this is basically in the MeV by c square unit that I did not mention. So eta is this much, k plus k minus, and again 1 2 3 2, that is what, that is the delta 1, I think delta or sigma, I also forget that one. 1 2 3 2 is delta, yes, like that, the mass, we have to check that. But yeah, 140 is very much common, pion mass is very much common. So, and that neutron mass 939, then proton mass is 938 point something, we don't need that much, but yeah, this type of values are there. So these are the cases, and maybe I don't have any more slides for today. So, oh, I have just finished that one very early today. So if you have any doubt or any question, you can ask me right now. Maybe I can go slowly from the very beginning, or maybe my
Hello, madam. I have a question.
yeah.
I want to ask that there are some questions like whether the reaction is valid or not, and there we are checking the lepton number, baryon number, and the mass. So
Charge.
I need to, charge is also there.
Yes.
So I want to ask that whether we have to remember the mass of all kind of quark particles, because different, like delta has some mass, neutron, proton is easy to remember, but there are then pions and kaons, all the mesons are there. So
Yeah, that's why I told na. Obviously you can't remember all the particles mass. That is impossible for only one person. So that's why what I told. Obviously, at least you can remember NP, then simply pi. Pi plus pi minus pi 0. Actually, pi plus pi minus pi 0 both have.
So they have the same mass.
Similar. 140 point something, 140 point something, like that. So it's very similar.
And then there is lambda 0. There are some reactions. There is that lambda 0 is there.
Yeah, but for these cases, like let's say lambda 0 is coming something plus something, most of the cases, if they are asking for the reaction is allowed or not, most of the cases they are asking for lepton number, baryon number, and charge only, because unless there is no mention of mass, I don't think that they will ask for mass. Actually, they will not ask for mass indirectly or directly, but let's say, okay, maybe we can tell one thing. I'm just giving one example, simple example. Yes, this one, this expression, right? This decay. In that decay, you can see proton is going to neutron plus pi plus. For this case, charge is fine. Yes? Baryon is fine. Very good. Lepton, there is no lepton particle, that is also fine. Now you can tell me, this is allowed or not?
Yeah, not allowed.
Yes. How you can say that it is not allowed?
Neutron has more mass.
Yes. So in a rest,
Neutron has 939 and proton 938.
yes, and then it is also 140. So
And pion is also there. Yes.
yes. So you can see for these cases, like let's say for p going to n plus pi plus, these type of cases we need to check the mass. But in most of the other cases regarding lambda, delta, sigma, whatever is there, in that cases, in most of the cases we will not take care about mass, because mass is already conserved there. Otherwise we have to remember all the masses each and every time. That is totally impossible. But for this case it is very simple to remember p mass, n mass and pi mass. For this case we can simply tell that that is not possible, obviously. And even this one is also not possible, because this is 939, this is 938. It's smaller than this one, but this is 140. But one more thing is there, in some advanced cases, I like advanced competitive exam or something, they are asking that this is possible or not in rest frame of n. When the n is at rest, that is allowed or not. When a neutron is at rest, that is not allowed, because mass conservation is not going to valid. But let's say our proton has a very much kinetic energy, very high kinetic energy. So obviously for this case, this process can be possible. This process is also possible when proton is not at rest. When proton has too much kinetic energy, so that the total energy of proton is equal to total energy of neutron plus total energy of pi plus, then there is no problem in energy momentum conservation or something. And after that we can say proton going to n plus pi plus can be a allowed reaction. But in rest,
Thank you, ma'am.
when proton is rest, there will be no possibility to get this reaction. When neutron is rest, there is no possibility to have this reaction. There is something.
Madam, can I explain in or can I ask in Hindi?
Yeah, sure.
ओके मैडम, ये जो पाई मेज़ान के उसमें आप चार्ज आइसोस्पिन क्वांटम नंबर हाफ ले रही हैं, बट इन सम बुक्स जैसे डीसी तयाल हो गया,
pi zero.
नो पाई मेज़ान, फॉर पाई मेज़ान द आइसोस्पिन क्वांटम नंबर इज +1.
हाँ, फॉर पाई के लिए 1 होता है, मतलब आई जो होता है वो 1 होता है.
हाँ, लेकिन आपने उसमें जो अभी लास्ट में बताया है,
कौन सा
जो
वाला?
चार्ट बनाया था आपने लास्ट का,
देखिए
यस,
एक मिनट.
और लास्ट यस
Oh,
यस
oh,
यस
oh,
इन
oh, sorry, this is a typo. Obviously it is
Yes.
1, sorry.
ओके, इट इज ओके, बिकॉज द पाई मेज़ान इज इन ट्रिपलेट स्टेट,
Yes.
पाई प्लस पाई जीरो एंड पाई माइनस.
इसमें ऐसा होता है ना, पाई प्लस पाई माइनस पाई जीरो. तो इसमें बेसिकली आई
Yeah,
अगर
yes.
1 होता है तो I3 will be
yes.
-1 0 1. Yes, it's typo. I did
Yes.
not see that. Yeah.
ओके
Yes.
okay.
And
Thank you.
eta 0. Oh, see, this is also typo. Sorry for all these things. Eta 0 has isospin 0 because eta 0 is only one family member in that family.
Okay.
Yeah. So family member, I think this term you are familiar, right? Because I am so many times I am using that family member because I like to remember in that sense. Because family member means if proton and neutron we will talk, there are 2 family member in that family, in that nucleon family. So that's why I will be half. How we can say that I will be half? Because 2i plus 1 should be the family member. So if proton and neutron in that family and there is 2 members in that family, so 2i plus 1 should be 2. So now you can see that 2i will be 1 and I will be half, like that. Family member means the same isospin should be there. So maybe sometimes family member, maybe you will see what is the family member. But yeah, family member means there are 2 family members means I will be half, 3 family member means I will be 1, 4 family member means I will be 3 by 2. Why it is 3 by 2? Because let's say 4 family members are there. So 2i plus 1 will be 4. So I is 3 by 2. Yeah, it was typo. I did not see that. Something is there.
அதுதான் வேற பாக்கி விட்டுருக்கு, அது இதே கூட பாக்கி விட்டு வராது. அதுதான் வேகமாக வாயில் அள்ளி போட்டு ஓடிச்சு. நான் சாப்பிடக்குள்ளே போய் கலந்துக்கணும்.
I can't understand the language, sorry. Hello. But what is the name? Pakiaraj.
Yes.
Yes. Can you tell me?
No, sir.
You raised your hand, so that's why. Do you have any question?
No, ma'am, no.
Okay, fine. Actually, I thought that you have some question. That's why you raised your hand. Okay. And whatever you told, I did not understand the language. Okay. So. And
I
yes.
have another question. So I watched your last practice session. So there you said something, a reaction, whether it is electromagnetic or weak interaction.
Yes.
Detect. So you said that for weak there will be neutrino present. Something like that.
If neutrino is present, obviously no doubt that it will be a weak interaction. It will not be electromagnetic, it will not be strong interaction, it will not be, gravity is already there, but there will be no electromagnetic, there will be no strong interaction, but it will be only weak interaction. But it is not, the vice versa will not be true. If neutrino will be there, in all weak interaction, neutrino should be there, that is not the true one, okay? But if neutrino is present, that means it is obviously weak interaction. That I am telling.
In the assignment, there was a question that whether a reaction is weak as well as electromagnetic.
Okay.
Both have to be present. So how are we going to how we are going to detect that?
Okay,
both have to be present, not any one.
Okay, I got it. But first of all, just confirm me that the deadline has already over or not. Because
deadline is over. It's, that's why I asked. I know within the deadline I shouldn't ask.
Okay, fine.
It was the last, I think, assignment 7 or something.
Okay, fine. This is assignment 7. Okay, fine, no problem. I understand. So if it is weak as well as electromagnetic, then how can we understand that it is weak as well as electromagnetic, right? So let me tell you one example, right? Let me write here. This one. Simple example. There is no problem on. Oh no, not this one. Sorry. Because nu is there, obviously that means it will be weak interaction. But let me write here one example. What I can write. This one. This one. So, E plus E minus going to mu plus mu minus. I think I have already shown the Feynman diagram. There you can see this is electromagnetic interaction because the mediator is gamma. But that can be also weak interaction. How? Because, let me write here. So, how we can see that it is gamma mediated? You can see it is like E plus, E minus, then the mediator was gamma, and it is coming as mu plus, mu minus. So, this is the Feynman diagram. But it can also be possible if I write like that, E plus, E minus, mu plus, mu minus, Z0. Now see, if it is weak interaction means for weak interaction the mediators are, I think I did not mention that one previous class, the weak interaction means the mediator will be W plus, W minus and Z0. And for EM, the mediator is gamma. So for this case, you can see this is also possible because this vertex, in this vertex, in this vertex, the charge is also fine. E plus, E minus and Z0. Mu plus, mu minus, Z0. Z0 means there is no charge, electric charge. So for this case, for this weak interaction case, the mediator is W plus, W minus, Z0. So if I will talk about this expression, that can be mediated by gamma as well as that can be also mediated by Z0. So this type of expression can be weak as well as electromagnetic. Now if I will talk about simply a Newey-like thing and then Newey-like thing, that will be only due to weak interaction. But there will be no electromagnetic interaction because neutrino is present. But it can be possible through electromagnetic as well as weak interaction. Is it fine?
Okay, and the correct answer that was given, something related to UD, that was also given. So I did not understand how the UD will be weak plus EM.
Okay. So what was the reaction? Can you tell me?
I don't remember the reaction. It was just the assignment 6, I think, first question.
I think I have that. Let me check. I don't know I have that one or not. Okay. Week 7 assignment. No, not week 7, week 6. Week 6 assignment. Okay, I think solution is also given there. Solution is also given, right?
Oh, okay. That how that is U turning to D. How that is a reaction?
Yes, U were coming to D bar. Okay, that is fine. I will tell that. But again, also that E plus U is going to E plus U. So this is okay. What is the question here? Which of the following interactions influenced by electromagnetic and weak interactions? Okay, fine. So let me. You can also see the assignment solution also. That is fine. But see, no problem. I will also check that. I will also explain. I think here it is already given. It is clear from Feynman diagram and okay, fine. There is no other Feynman diagram here. It is given. Okay. So what was the expression? The expression was let me write here. The expression was E plus U going to E plus U, and then another one is U bar going to D bar. Okay. So E plus. Okay. Obviously, you can see that E plus U. That means obviously, if I write here E plus. I mean, like one E plus is coming, one E plus is again going, and then it is gamma, and it is U. That can be electromagnetic interaction, right? Because E plus is coming, E plus is going, U is coming, U is going, and it is mediated by gamma. So that is weak electromagnetic interaction. Okay. So yeah, this Feynman diagram is possible because you can see that there in that vertex.
That one is possible.
Yeah, that only this one is a possible one, because obviously this will not be possible one. E plus U gamma, it should not be correct one, because E plus and then it is U. It is not possible because U has a 2/3 charge and it is plus 1 charge. Obviously it will not be possible. Now coming to W, weak interaction, it is applicable or not. So for weak interaction case, weak interaction is mediated by W plus W minus Z0, as I told you. So one case can be possible that this can be also governed by Z0. Okay. Yeah, that can also governed by Z0. So if it is governed by Z0, then E plus coming, E plus going, U is coming, U is going through Z0, and Z0 does not have any charge, so there is no problem. So that can also be possible. But one more thing is that I can tell you one secret. Secret is not that much, but yeah. In most of the lepton cases, obviously not all the cases, that's why I will not tell that is the extreme secret. The secret is that in most of the lepton where it will be present in any reaction, most of the cases will be governed by weak interaction. Most of the, but not all the. I am emphasizing that one very much. If lepton is present in any nuclear reaction, most of the cases it will be weak interaction. But obviously electromagnetic should be there, that we have to check. But most of the cases it will be governed by weak interaction. And lepton means here E plus is lepton, so obviously it can be governed by Z0. Okay, now coming to U bar D bar. Now U bar going to D bar. For this case, I can write one Feynman diagram. U bar. So if I write here U bar, that means whatever it is the charge 2/3, that will be minus 2/3. So this can govern by gamma, and then it is D bar. Is it fine? because this is minus 1 by 3, this is plus 1 by 3. So this vertex does not have any size problem. That can be done. Again, it can also be done by Z0. Now you can tell me that there is no lepton, then how can it be Z0? That's why I told most of the cases lepton should be there in that weak interaction, but not all the cases. I mean, it's not true that in all the weak interaction lepton should be there. Here lepton is not there, but still the process can be done. And obviously you can see gamma Z0. And one more thing is there, W plus W minus. These two will not be the mediator when the interaction is EM as well as weak. Because if EM is there, that means obviously gamma will be there. So if gamma is there, W plus W minus cannot be there because this is a charged particle. So Z0 only the possible one to interact.
Okay, ma'am. Thank you, ma'am.
Yeah. But if neutrino is present in any nuclear reaction, without seeing anything, you can tell this is obviously a weak interaction. Because neutrino only interact with matter through weak interaction. That's it. Okay, so I can see this has already done. Yes, this has already done. So what about week 7? The deadline is still there maybe. 11, today is 6. Okay, so this is not yet done. Okay, maybe there is something. Hello? Yeah, you can have any question. Who is that? Vinod Yadav. Okay, maybe you don't have any question. See, in that assignment 7 also you can have very similar questions whatever I told. Okay, fine. Very similar question. Okay. What is there? Tell me. You can unmute yourself. Otherwise, how can I understand? Yes, Vinod, can you? I think you are unmuted also. Can you tell me what is the problem? What is the doubt? What is the thing you want to know? Maybe you are not audible. You have raised your hand. Can you tell me? Am I audible? I think yes. Something is there inside. This is the question solution of Q2 in assignment 5. Solution of Q2 in assignment 5. Okay. Assignment 5 solution. First of all, I need to check what is the question. Q2. Okay, let me check the question first. Question. Sorry. Something beta decay to something if their atomic masses are this and this respectively, what is the Q value of the reaction in MeV units? Okay. I think I have already explained like that. But what is the problem here? After the atomic masses are what is the Q value of the reaction? To find the Q value of beta decay, we use the following formula. What is the formula? This one, right? Substitute the values into. Yeah, this is correct. And finally the Q value is something into 931.5 MeV. And the Q value is this one. Thus the Q value reaction is approximately this one. So, where is the doubt? Ti minus V minus 2e. Fine. It is beta minus beta. It is beta plus decay, na? So for beta plus decay, I told you that the atomic mass atomic mass of parent particle minus atomic mass of daughter particle minus 2me should be there. So can you tell me what is the problem here? Ma'am, I think it is wrong. Ma'am, in question 2 there is essential. Okay. Okay, wait. V. That. Okay. But the mass we need, na? We need to take care of mass. So mass is there. If mass is there, then only it is fine. Like 42.96, whatever. Beta plus means what? Beta plus means obviously it will be 22 to 21. Yes, 22 to 21 it should be. So scandium should be there, but Sir was telling it is vanadium. Okay. Yeah, that is wrong. Obviously there will be 21, but we will need to check the value of mass only. That's it. Okay, so we have to focus on mass because they are asking us about the value of Q value. Yes, you told that it is correct. Whatever you told, that is correct. That it is scandium and there should also be scandium, but it is writing as vanadium. But for this case, for this question at least, we need to check only the case of mass. And if mass is fine, then there is no problem. Do you got my point? I mean, as it is only the Q value calculation, so we need to check the mass, atomic mass only. So if it is mass, then it is fine. And obviously whatever you told, that is obviously correct. I have no doubt on that. It is scandium and it should be scandium in the solution also, but maybe it is a typo and all this. You can see this one also, it is also not correct. Vanadium should not be there, it will be scandium. But the main thing is to calculate the Q value, we need to check the atomic mass only. So the answer should not be different. And obviously we don't know exact value of vanadium atomic mass and scandium atomic mass, right? So whatever the question will given, that according to that we will calculate. Is it fine? Yeah, obviously whatever you told, that is absolutely correct. I am totally agree on that, but as per the mass calculation, mass constant, there is no problem. We just need to minus 49 point, this one minus this one, minus 2 into m, that's it. Into 931.5, which will convert it in MeV unit. Okay, any other doubt? Because I have all the assignment questions here on my hand. Oh, maybe Sir was talking about this one. See, there is vanadium. Maybe there was a little bit mix up and all. Vanadium was there and maybe he was writing here vanadium. But yeah, fine, whatever. Okay, so any other doubt regarding today's class, regarding other class? So, by the way, how many of you got full marks in the assignment till now? Any type of assignment, any assignment, 1, 2, 3, 4, 5, 6. Anyone is there who got full marks? I'm just asking, okay. Just, it's not a formal thing, I'm just asking because I am not in that evaluation section, so I don't know how many of you got how much number. I'm just asking for the answer. No? Okay, fine. Yeah, it's fine, no problem. Like, obviously, full marks should not be there, but yeah, you have to understand that one properly, that is the main thing. Okay, so if there is no other question, then we can stop today's class and we can meet in the next week. Is it fine, everyone? Should I stop? Okay, maybe there is no other question then. Okay, bye bye.